did actually.
All right, so let's have a look. What page are we on?
36.4. 215.
215. Okay. All right, so let's go through. Let's start with 217. I'm going to start on that working example too. Okay. So it says solve the equation sine squared x equals tan x cos x algebraically in the domain of 0 to 360. So, oh shoot, I gotta just save this. Sorry. Okay. Tan x cos x. Okay, so again, one of the major things when we're solving these questions is we basically have to do our best to make sure that we're working in the same trig function. All right, so we would want to get this all equal to 0. So I go sine squared x minus tan x cos x. So I have that so far, right? Now, I can't factor this. I don't have a greatest common factor, so I need to see if there's a way that I can simplify this. So the best thing to do for almost all of these questions is change them all to sine and cos. So I would change tan to sine x over cos x. Equals 0. So now the one thing that I do have to identify sorry, I got one of my grade 11s here. Okay, so one of the things I have to also identify is that cos x is the denominator. So that means that I have a non-permissible value. So where cos x can equal 0. So because when I'm solving this now, I need to know what values of x work and don't work. So where cos x can equal 0 is pi over 2. Well, actually, we're in degrees for this, right? So my answer cannot be 90 or 270. Okay, because it says from 0 to 360, and I see that cos x can equal 0. All right, because it's a denominator. So now, cos x divided by cos x is that. So now I'm left with sine squared x minus sine x equals 0. Now I only have to work with sines. So what do I do here? Factor out sine x. So I have that. So where sine x equals 0 and sine x is equal to 1, x is equal to. Okay, so where is sine x equal to 0 on my unit circle? Oh, I keep going with radians. So sine x is equal to 0 at 0 and 180. It would be 360, but my domain says that it's not equal to 360. And then where is sine x equal to 1? At 90 degrees. So here's my solution. 0, 0 degrees, 180 degrees, and 90 degrees. However, I look up at my non-permissible values, so I have an extraneous root of 90 degrees. So my solution is just 0 degrees and 180 degrees for this question. Okay? So going through this, again, simplify from there, and then it just goes back to factoring and solving using the unit circle. If these values were not on the unit circle, then I would have to use my calculator for it. All right? Questions? You're okay? Thumbs up for okay? Yeah, go ahead, Mary.
So again, why isn't it 90?
Because
90.
I have tan x is sine x over cos x, right?
Yeah.
Okay. Now cos x, that means then that cos x can't equal 0, because I can't have the 0 as a denominator. So now you look on your unit circle, and what are the two coordinates on the unit circle where cos x is equal to 0? That's at 90 degrees and 270 degrees.
Okay.
Okay?
So that's your non-permissible
Yeah.
value? Okay.
That's my non-permissible value. That's correct.
Okay.
All right?
Yeah.
Okay. Perfect. So let's look at 217, example 3. The ones that are going to be a bit of an issue for you are these double angle ones. And the reason that the double angle ones are going to be a bit of an issue is because you have to go more than once around the circle. All right? Because you can have values that are, because you're always dividing the angles by 2, you need to go around the circle at least 2 times. So let's have a look at this. So I've got cos 2x is equal to root 3 cos x minus 1. Like that. Okay. So the other thing that I have to recognize is I can't work with a double angle, a double angle and a single angle. So I want to always convert my double angles to single angles using my, identity. So look at my identity. There are 3 separate identities that deal with cos 2a. One that I want to use. All right, I want to use the cos x one. Okay, so what's the identity for cos 2x? So 2 cos squared x subtract 1. That sound right?
See, I thought it was like the cos 2a, but
It is. It is. It is. It's just I'm using x instead of a. Okay, so that you're still doing the same thing. What page is that on? There it is. Okay, so cos 2a is either cos squared a subtract sine squared a. That doesn't help me because that's still a cos and a sine. 2 cos squared a subtract 1. That's the one I want to use. So I'm going to change this to 2 cos squared x minus 1. I'm substituting that in for cos 2x. That's equal to root 3 cos x minus 1. Get it all on one side. 2 cos squared x. I'm going to subtract that over, so that's root 3 cos x. And if I add 1 to both sides, I actually end up with it equaling 0. So I've got 2 cos squared x. I subtracted root 3 cos x to this side. And when I added 1 to both sides, they all canceled. So now I have a binomial, and I want to factor out the greatest common factor here. So the greatest common factor is cos x. So I take a cos x out. Now I'm left with that. So where on the unit circle is cos x equal to 0? Where on the unit circle is cos x equal to root 3 over 2. And it says give the general solution in radians. Okay. So the first, go ahead, Dalen.
Is it negative root 3 over 2?
No, it's positive because I'm going to add root 3 to the right side and then divide by 2. All right. So in radian measure, go around the circle one time. X equals. So where is cos x equal to 0?
270.
Right. Pi over 2 and 3 pi over 2. Right? Okay. Where's cos x equal to root 3 over 2?
330.
Pi over 6.
Pi over 6?
6.
Yeah. And
11 pi over 6.
11 pi over 6. Perfect. Okay. So now, here's the one catch that you haven't seen, or you have seen, but we have to add it on here. The domain was given as general solution in radians. So it wants the general solution in radians. So what I have to do to this is I have to show where the angles are all coterminal to these angles here. Where are they coterminal? So how do I show an angle that's coterminal to it? What do I have to add to it?
2 pi.
2 pi. So what I do is I go plus 2k pi plus 2k pi plus 2k pi. Oh, that's the k. Plus 2k pi. And just write it over here for fun, where k is an integer. All right.
Is that 11 pi over 6?
Yes, it is.
Yeah.
Yeah, that'd be 330. Okay, so far? So in the last section, or the last unit that we did in chapter 5, or chapter 4, we've done from here down. We've done this already. We did this before the break. We did all of this, okay? The only thing that we have changed in this chapter is we've added in this whole part with the identities, changing this to this. That's all we've added in this section to what we've already done. Okay, so we should be able to go through this and use our unit circle and work on it. Okay? So let's look at, I'm going to do the example 4 with you now.
So there won't be any videos tomorrow, right?
No, tomorrow's,
Friday, right?
yeah. So there's nothing happening tomorrow.
Is there a PD day today?
PD day today?
No, like a half day today.
Today's
It's
Thursday.
Oh. I don't even know what day of the week it is.
Yeah.
I don't think it would matter if it was a half day or not either.
Yeah, it doesn't.
matter.
No, we're
I
not.
was just curious if you guys still have to do like your whole like half day.
Well, probably not, because
We had our first meeting since all the breaks on Microsoft Teams on Monday, or Tuesday. Sorry, was the first day that we all met. That we've talked to anybody since we started this whole thing. So I'm just treating it like this is what I'm doing every day now. And that's the way it's going to be until we get to the end of June or middle of June, whatever.
You want that assignment due for Monday, or?
Yeah, I prefer it in Monday by noon. Yeah. Everybody's been able to access it using the OneDrive? There you go. Okay, so at some point in the next hour here, try and access it using the OneDrive. There is an app you can download for OneDrive as well.
I just went on the app right now, and it just says all the folders are empty. It says like I'm in your class and everything, but it doesn't say there's anything there.
Oh, George is on here. Sorry.
She said that her Wi-Fi wasn't working.
Yeah. Okay. All right. It shouldn't be empty. I put one in this morning.
Okay. Okay, so the one I should be in should be. I think I'm only in physics right now.
Yeah, there's nothing in physics. The pre-calculus one has a chapter 6 assignment in it.
Okay, let me see.
Are you on the app, or?
I'm working on it right now.
I don't even have the class anymore. It just says Mountain View School Division.
Yeah, I can't see anything on my OneDrive.
Okay, I don't know. I just refreshed everything here to make sure.
Should there be a class, or should it say PreCalculus?
Yeah, I have a folder, and my folder is shared. Let me just see.
Because I don't have anything.
You know what you have to do, Brendan? You'll have to copy that link off of Edmodo.
Oh, okay.
Okay?
Okay.
I can email that link to you right now if that's a problem.
Maybe. That's okay. Are you just gonna email on the MBSD account?
Yeah. No, everything's gonna be MBSD. Mary, do you want me to email that to you too?
Yeah.
Did you hear from Rex at all?
I haven't heard from him yet.
Or Eli? Did Eli talk to you?
Eli has signed up for Edmodo, so that's the first step.
He's trying to get something going, I think.
Pardon me? Roy?
He's trying to figure stuff out right now, but
Okay.
really bad Wi-Fi, I think.
Yeah, no, I understand that. I still think, I know Eli, he can YouTube. As long as he can YouTube, he should be able to access all this stuff. But I mean, if he can't, he has to send me a message, and the only thing I can do is I don't know how I get it to him, unless he comes into town and picks it up at the back door. But anyways, we'll figure that out as we go. Okay, so some point here today, go in, you have to copy the link from Edmodo that I put on there in order to access the file folder. Okay, actually, now that I think of that, just texting Morgan, I'm on. Copy.
Has anybody heard anything from Morgan?
Oh, I have. He sent me Petra's assignment this week. That was Morgan McFork. Okay, let me just do this one last question, then I'll answer questions for you. Okay, so I have 2 cosecant squared x plus cosecant x minus 1 equals 0. And it says, again, give the general solution. So when it says give the general solution, that means, Daylin, this is page 218, example 4.
Yeah, I know, I just can't see very good.
Well, that's what I mean, like, follow in your book if you can't see my board well. I'll change the color. Everybody's been saying red seems to work a little bit better. Okay, so I'm going to factor this guy now. I Again, I'm going to speed factor. So 2 cosecant x minus 1 cosecant x plus 1. Okay, so now I have, sorry, that's crammed in there. I have cosecant x is equal to 1/2, and cosecant x is equal to -1. All right, so first things first, I just treat it the same way I treat everything else, and I factor it. So I factored it down. I see that cosecant x is equal to 1/2, and cosecant x is equal to -1. So now at this point, I probably want to convert it to sine now, all right? Because I can't solve anything with cosecant, but I can with sine. So this makes this sine x equals 2, and sine x equals -1. All right, I reciprocate, okay? I reciprocate that. So that's 1 over sine x equals 1/2. So therefore sine x equals 2. Sine x equals -1. So where in the unit circle does sine x equal 2?
Isn't that the cosecant x is equal to -1?
Yeah. So
I guess 1 over -1 is still -1, yeah.
Right. Okay, so back to my question. Where in the unit circle is sine x equal to 2?
Good question.
Everybody's stumped. Everybody's stumped. I want you to look at something. All right? I'm going to draw y equals sine x for you. Okay? There's y equals sine x. You agree with me? What's my maximum value?
1.
1.
What's my minimum value?
-1.
So when I look at all of the possible ratios between 0 and 360, what's the maximum value? And what's the minimum value?
-1.
So if I'm anywhere outside of -1 and 1, there's no solution. There's no solution.
Undefined.
So there's nowhere on the unit circle. You're stumped because it doesn't exist. All your sine and your cos graphs have to be between -1 and 1. All right? Where on your graph does sine x equal -1?
(3π/2).
Yeah.
And because I asked for in general solution, what do I have to add on to it?
KPI.
What do I have to add on to it?
2k pi?
2k pi.
Yeah, I was guessing.
Don't admit when you're guessing. All right? So that's the solution for that question, okay? All right. That's all that I have new for you right now. Were there any questions from the assignment yesterday that you want to look at?
On page 192,
Yeah.
I got C and D for number 1, but I don't really know how I did it.
So it's asking you what the non-permissible values are. Okay, let's look at C. So
I know it's like where sine is equal to 0 plus 1,
okay.
right?
So, well, yeah, let's just go through the whole thing so that we understand the y's, okay? So you understand that I can't have this. I can't have 1 over 0, right? Like I can't have a 0 as a denominator ever. Agreed?
Yeah.
Okay, so right now looking at this, the way it's written, without making any adjustments to it, I understand that 1 plus sine x can't equal 0. You agree?
Yeah. So then it's like where sine is equal to -1. I get that.
Okay, so then x is, so where does sine x equal a -1?
3 pi over 2.
Right, so 3 pi over 2, and if I'm listing them all out, I add 2k pi to it, okay? So that's, I know, sorry I wrote that small. Okay, so that's 3 pi over 2 plus 2k pi. So that's the first part. So that's without touching this question. Fair enough?
I'll be right back. There's a cow in front of my door.
Well, feed it. Okay? All right. Cotan x. Cotan x. So now I'm going to, because I proceed along with simplifying, cotan x is cos x over sine x. So I also have to acknowledge the fact that the top part is a fraction as well, and the denominator of the top part is sine x. So sine x also cannot equal 0. So where does sine equal 0 on your unit circle?
Well, pi and 2 pi.
Right, so
And 0.
right, so add all your pi values, right? So I write that as k pi, where k is an integer. Okay, the alternative to doing that, the alternative to writing k pi would be to write pi and then add 2k pi to it, and then write 2 pi and add 2k pi to it. You can do that, but it's redundant. K pi represents all the pi values around the circle: 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, -1 pi, -2 pi, -3 pi. Okay, so it represents all of the pi values going around the circle. All right? So does that help with your understanding what you did?
Yeah, like the only thing, like I got everything. It's just the way I expressed it because I'm doing it wrong.
Right, and that's the part that we have to get better at, is expressing it in that sense.
Yeah, I figured it out. That wasn't my issue. It's just I didn't do it right.
Okay. You see how to write it correctly now?
Yeah.
Okay. All right. Any other questions today?
Can we do 4?
Yeah.
Yep. So it wants us to verify that the equation cosecant x over tan x plus cotan x is equal to cos x is true for 60 degrees and pi over 6. All right, I'm going to do something different. This goes along with 6.3 on proving identities. I'm going to simplify the left side first. I'm going to show you how the book's doing it with 60 and pi over 6. So I'll show you that after. But I'm going to show you how to make the left side equal the right side. This is what 6.3 was. I feel like there's some real good skills that you should use out of it, but it takes a lot of time to do these skills, so I don't want to waste time on it because we've already lost a few days. So the long and short of it is this. I draw a line down. I'm going to get the left side to equal cos x. And so to do that, I need to make some changes, and I have to work with the left side and substitute some identities in. Okay? So cosecant x is 1 over sine x. Tan x is sine x over cos x. Cotan x is cos x over sine x. Okay, I know, is that hard to see?
No.
We're okay? All right. So now, here's a neat trick I learned a few years ago. And when you're dealing with fractions and over fractions, I could get a common denominator on the bottom, multiply by the reciprocal. I can do all of that. But what I'm going to do instead is I'm going to multiply everything by sine x to begin with. So all three of those terms by sine x. And then I'm going to multiply them all by cos x, and that's going to get rid of all my denominators in total. So watch what happens here. I'm going to times this by sine x, this by sine x, and this by sine x. Like that. Okay? So this sine x divided by that leaves me with 1 on top. On the bottom, I have sine squared x over cos x plus that sine x and that sine x cancel, leaves me with cos x. Okay, so what I've done is I had 3 fractions there. Now I'm down to 2 fractions. So I want to get it down to 1 fraction. So to do that, I'm going to multiply everything by cos x. Okay? So all I'm doing is simplifying fractions to make my life easier. So I'm going to multiply everything by, excuse me, cos x. So I'm going to times this by cos x, this by cos x, and this by cos x. So on top, I have 1 times cos x. That's cos x. Right here, this cos x and this cos x cancel. That leaves me with sine squared x. And then I have plus cos squared x. So what I've gotten myself down to by changing everything at the start to sines and coses, I multiplied by the denominators to get rid of both denominators, the sine and the cos. And I'm left with cos x over sine squared x plus cos squared x. So far, so good. I mean, I know it's a little bit confusing, but at this point right here, can somebody tell me what sine squared x plus cos squared x equals?
1.
Yeah, it does. So I end up with cos x, which is equal to the right-hand side.
See, I did like almost the same thing, except I just made them like common denominators
Yes.
on the bottom. So I did like just times the other side by cos x and times the other side by sine x, and then that was equal to 1, and then I just reduced it to cos x.
Yeah. Yeah, that's okay. That's 100% okay. I like that method. That's perfect. Okay. So that's how I would do that. So this is what we call a trig proof. You're trying to prove an expression, an equality that the left side is equal to the right side. All right.
Sorry, I'm a little lost. How do you figure out for sure how sine x squared plus cos x? How do you know sine x squared is 1?
That's the very first identity you learned. It's the very first.
Oh, yeah, that's 1/2. Yeah.
That's Pythagorean. That's the Pythagorean identity. Sine squared plus cos squared equals 1.
Okay.
Okay. All right. So now, to do this question differently, to use the angles, Mary, I would do this again. I would convert one more time. So I'd go 1 over sine x. But in this case, I'm going to put 1 over sine 60 degrees equals tan of 60 degrees plus cotan of 60 degrees. And that should equal what the cos of 60 degrees is. So the cos of 60 degrees is a half. We know that, right? From our unit circle. Okay, so what's the sine of 60 degrees?
Root 3/2.
Yeah, so I have 1 over the root 3, 1 over root 3 over 2. The tan of 60 degrees. What's the tan of 60 degrees? The tan of 60 degrees is root 3. And the cotan is 1 over root 3. So that's what I have there. So now I need to simplify this again. Okay, so this is why I don't really like this method, because I'm still doing a whole bunch of fraction work. But anyways, 1 over root 3 over 2, that's just 2 over root 3. And on the bottom, I have root 3 plus 1 over root 3. So here's what I'm going to do. This is exactly what I did on the last page. I am going to multiply everything by my two denominators. So I'm going to multiply this by root 3, this by root 3, and this by root 3. That cancels and leaves me with 2. So that root 3 and that root 3 cancel. Root 3 times root 3 is 3. That root 3 and that root 3 cancel. It leaves me with 1. So now I have 2 over 3 plus 1, which is 2 over 4, which is the same as my 1/2. Okay? So the part that I don't like about this is there's a lot of fraction work still. All right? And unless you know that little trick to multiply by all the denominators to get rid of the denominators, you're having to get a common denominator, you're having to reciprocate. It's a lot of work. It's a lot of work. Okay? So those are the two methods that you use to solve that question. And it's not easy. I understand that. There's a lot of work to it. All right? Other questions today?
Would you be able to do, I don't know why I couldn't get it, number 3C on page 192?
3C?
Yeah,
Okay. Sine x over 1 minus cos squared x?
yeah.
Is that the same thing as the cos squared x is plus sine squared x is equal to 1?
Yeah.
Then 1 subtract sine x squared, so that's what it's equal to.
Yeah.
So then, yeah.
Okay, Rory, the very first identity that we're looking at is called the Pythagorean identity, and that's cos squared x plus sine squared x equals 1. That's the first thing that we learned in this, right?
Okay.
Okay, so if I arrange that differently, Rory, if I take the cos squared and I move it to the right side, I'm left with this. I'm left with that, right? sine squared x is equal to 1 minus cos squared x. So then I can substitute in right here. I get sine x over sine squared x.
Okay.
That cancels, leaves me with 1 over sine x, which is cosecant x.
Okay.
All right. That Pythagorean identity is the most important identity you can know in this section. You're going to use it. You'll use it a lot because it's the one way that you can convert from a sine to a cos. It's the only way you can convert mostly from a sine to a cos.
Okay.
All right. Okay. Anything else?
Are we going to be doing any physics today or no? Just keep going.
Yeah, we could do some. Sure. Let me finish up here, and then if you want to do some physics, I can do that right after. Okay?
I didn't do physics yesterday.
Okay.
Sorry.
I just watched a YouTube video yesterday.
Okay.
Yeah, I that for the video too.
So, what did you have? Okay. What did you have physics-wise? You had a couple questions on two questions on 452, and then those problems on 457. I would look at doing those on the weekend.
Would those all be in just this?
Well, it actually says it on there. So look in that page. It says do questions for page 452, and then it says do questions on page 457.
Oh yeah, right there.
Okay. So if you do that,
54.
if you do that this weekend, try and do that for Monday. I'll go through all those questions with you on Monday.
Okay.
Okay. Any other questions with your pre-calculus this morning?
Just for that, what?
Just make sure you can access that worksheet.
So for OneDrive, I take the link off of Edmodo and then paste it into the app.
I honestly, I don't know, Rory. I'm not sure.
Is there any way you could send a new code for Edmodo? Because I use like everything on my iPad now.
I don't. Just a second.
I have the normal on my phone, but I can't do it.